In this lesson, we're going to be dealing with routing concepts, the second part. And specifically, we're going to be looking at routing instances, which is a very cool feature that Junos offers and makes Junos routing very flexible. Okay, so pretty much Junos routing tables is going to be the first of our topics, which is going to help us understand better the topic of Junos routing instances. Are you ready to go? Let's go. So there are multiple routing tables on a Junos device, on a Junos routing device. Okay, the first one is the inet.0. inet.0 is your regular IPv4 routing table or routing instance. Okay. Also, there is inet1 or inet.1, which is a multicast forwarding cache. This is used when you're running multicast. Now, before we continue, we're not going to go through each of these in depth in labs and everything because it's not part of the curricula. However, you do need to learn them as part of the curricula. You need to learn what each table does. So, just the table and what it does. Okay. inet.2 deals with MBGP or multicast BGP RPF checks. That's what inet.2 is for. inet.3 is populated with MPLS path information. So that's for running the MPLS protocol. So inet.4 is used to keep entries from multicast source discovery protocol. inet 6.0, as the name might sound, it's the actual IPv6 routing table. So IPv4 routes and IPv6 routes are not kept in the same table, but in different tables. And then MPLS.0 is the MPLS next hops table. Okay, so now you learned what are the tables that Junos will use by default configuration. Okay, and of course, if you're for example not using IPv6, you're not going to have an inet 6.0 table populated and shown in your show route command. Well, because you're not using the protocol. Okay. Keep in mind that if you start using the protocol, you will see on the output of your show route, for example, a new table called inet.6. And the same will happen if you're using multicast, MPLS, or some of the other features for which Junos keeps separate routing tables. Okay? Now, what if we could create our own routing table? Well, is that even possible? And what for? And that is what routing instances are for. Routing instances will allow a user to create a custom routing table for the purpose of network virtualization, routing separation, having separate routing domains within the same device, and for so to speak, virtualizing in a way that one router can become several routers. Such is the concept behind routing instances. Okay, so again, they are user-defined routing tables. They will provide network virtualization since a single device emulates separate routers. Then any single logical interface belongs to only one routing instance. This is important for you to know, as you cannot assign the same logical interface to more than one routing instance because an interface must belong to a router only. Make sense? And then there are different types of routing instances which exist for different purposes. And we're going to learn about one of them called virtual router in this series. Okay. So let's talk about the routing instance types. There is one called the forwarding instance. Okay, this is used to implement filter-based forwarding. Filter-based forwarding is a way to alter the default routing behavior, helping yourself with firewall filters. Okay, in some other environments, it's also known as policy-based routing. Layer 2 VPN routing instance is using layer 2 VPNs. Okay, for service provider environments mainly. No forwarding is just used for administrative separation and no forwarding routing instance. A virtual router routing instance, this is the one we're going to be working with in this lesson, is used for routing device virtualization. Okay, so you create separate routing tables within the same device that they cannot communicate with each other, but can forward traffic to networks connected to them. Okay, then there are BPLS routing instances, again for BPLS layer 2 implementations, mainly used for service provider environments. And then there are BRF routing instances used for MPLS VPN layer 3 implementations. Now, I don't want to keep these very abstract, okay? I want you to understand it, and the best way to understand it is to practice it. So let's go ahead and let's create a lab on defining a routing instance, assigning interfaces to it, and seeing how routing instances interact with the default routing instance of the router and what possibilities and limitations we have. Okay, so I have attached to this lesson a separate PDF file which contains this topology. Okay, it contains it in 3 different slides because we're going to be working in sections. The first thing we're going to do, as you can see here on this particular slide, we're going to define in router A and router B fast Ethernet 001.0. Okay, and we're gonna give that interface an IPv4 address and an IPv6 address for each of the routers. Very simple task that you should already know how to do from the previous videos of the past series, but this is where we start in this lesson. Okay, as a matter of fact, no, we start with something else. I will not assume that you have a clean router. I will assume that you have a lot of configuration from following all the courses and practicing a lot. So I'm hoping that is the case, right? So I'm gonna show you first how to wipe it out real fast and have a couple of fresh routers for this particular course. Okay, so here I have router A. If I do just a simple show, I'm in edit mode, right? I can see there is a lot of things here. Well, I don't want anything to distract me, and we're just gonna focus on routing in this course. So I'm gonna start deleting section by section. So delete interfaces. We're gonna define new interfaces. Delete system. I just don't want anything else in the configurations. I'm deleting everything under the system hierarchy, including services, SNMP, whatever there is there. No, SNMP is not under system though, but whatever is there, okay? Delete protocols. So I delete protocols, so we can start with fresh routing. Delete routing options, same purpose. Okay. Delete, let's see, are there any routing instances? Delete routing instances. Delete SNMP, is there we're gonna delete it. Let's do a show. There you go. That's what I want to see. Okay, the only things that's here right now is security, forwarding options, family INET 6 mode packet based, and family MPLS mode packet based. Okay, I'll give a candy to whoever can tell me what do we need this for. No, I'm just kidding, because we are remote. But do you guys remember what this is for? This is for converting your SRX firewall into a router. So it does not process traffic as in flow mode, but as in packet-based mode. Okay? So remember, this is crucial to have. If you do not have it, please go ahead and check. If you do not have it, then these are the commands. I'm gonna just do show match security display set. This is crucial because else things are not gonna work for you if you're running this device as a firewall. So you need to make sure these commands that you see right here have been set up, and you need to make sure that if the router tells you you need to, you have to reboot it. after setting this up. Actually, whenever you pass from one mode to another, you have to reboot the router. You can pause the video and do it if you haven't. Okay? One more thing. If I hit commit right now, what's gonna happen? The router is gonna cry because there is no password because I deleted the system hierarchy. So let's go ahead and set up a password for a root user. Set system root authentication plain text password. Confirmation, and there we go. Commit comment. I'm putting my initials here, jbar clean config. Okay, so it took a while, but here it is, commit complete. Now, I would like to ask you to do the same on both your routers. Just make sure the only thing that remains there is your root password and your settings for using packet base in both IPv4 and IPv6. That's all you need to have. So please pause the video, go ahead, do it in the other router, and we'll come back in a second. Okay, so now that we have wiped out any configurations from our SRXs that we're using as routers, let's just have a look at the actual topology we're going to be working on. So if you notice, in this lesson I also have included a PDF file which includes this topology, as well as the upcoming 2 slides which deal with different versions of the same topology with different information. So I did this so it's cleaner, so when you configure you can also be looking at your file, maybe on a separate monitor if you have one, or simply you can toggle between screens. And then the first thing we're going to be doing is we're going to configure router A and B's fast Ethernet 001.0. We're going to be configuring them with an IPv4 address and an IPv6 address. And to begin with, this is not going to be anything new for you guys because you've done that before. You've configured interfaces in previous courses. The difference is going to be on the second step when we're working on fast Ethernet 002, because then we're going to be working with an instance which is not the default instance. Okay? But for now, let's just start with router A and interface fast Ethernet 001.0. Okay, so you know the command, set interfaces fe001.0 family inet address, and then according to the diagram 192.168.30.1/30. That's our inet or IPv4 address. Now for the IPv6, it's almost the same, but inet 6, and then the specific format for IPv6 addresses. So in this case, it's going to be FE34 3606 5599 0A E6, and then double column. You remember these abbreviation rules for IPv6. So double column means a set of zeros are padding the rest of the hextets, and then a number 1, and then /64. And I can see there's an error bothering there. And what is this all about? It's all about missing the word address. Okay, there we go. Now before committing any changes, please always get into the habit of doing this show pipe compare command, which is going to show you whatever changes you've done, and it'll allow you to spot any possible errors or typos you may have. So in this case, it all seems good according to the diagram, and we're gonna just commit it. Commit comment jvar fe001 config. I think that's clear enough for a comment. And then the only thing we need to do after these commits is doing the exact same operation, but with the values corresponding to SRXB in SRXB, of course, or router B. Excuse me if I repeat SRX, and maybe, I don't know, maybe you have a lab with actual routers, like enterprise routers. It's just I'm assuming most of the people are going to be using the virtual SRX or a small SRX for practicing purposes. So I'll just try to stick with router A and router B from now on. Okay. So router B, that's where we're at right now. Hey, and it would be a good idea, since I wiped out all the configuration, just to set up the actual router name again, right? Set system host name, router B. Yep. Okay, so now let's do the actual interface. Set interfaces FE, well, that's GE, FE 001.0, family INET, address 192.168.32/30, and then the same thing, but INET 6. And this one in this case would be FE34 36. Oh, you see, this was my error, because I'm reading from notes. I will have to go back and correct this on the previous configuration, because I put in the previous configuration 3606, but the case was 360C according to the configuration, and I misinterpreted my own handwriting. Just imagine how bad my handwriting is that it confused myself. But please be aware that I'm going to correct this, and it was wrong on the previous video. And if you followed exactly what I was doing and did not notice it, you will need to go back and correct it as well. Right, show pipe compare. See this? Missing mandatory statements, root authentication. This is because I had wiped out all the configuration. I didn't put a password. Set system root authentication plain text password. There we go. Commit comment. Okay, commit complete now. And what I'm gonna do is I'm just gonna go real quick and fix my error in router A. And I'm noticing router A doesn't have a name either. I didn't know what I was thinking. I did not remember to put it back. So I'm just gonna do it again. Okay. And then edit. This is good that it happens. You can also see how to fix things on the spot real quick. So edit interfaces, FE 001.0. Okay. Family INET 6 address, or just family INET 6. There we go. So I'm now in that part of the hierarchy. If I do a show, all there is in here is address. So this is what I do when I need to correct a typo. It's so easy just to place yourself in a hierarchy where you can use the replace pattern function. Remember, the replace pattern function, what you need to be careful about is that it'll work in everything that matches your string, which is below the current hierarchy. So you want to be on a very specific hierarchy to use it, else you will be modifying other values in the rest of the configuration that you might not want to modify. Make sense? That's why I am going specifically to the family INET 6 hierarchy all the way down, and I do replace pattern, and there's only one string with 3606, which is this second hexed right here. So I'm just gonna replace pattern 3606 with pattern 36O-C, which was the intended one to begin with. I do a show, and nothing happened. I mean, nothing bad happened before, but it did change the statement that I needed to change, okay? So it is now 36O-C, as I wanted it to be. Top, commit, comment, jbar fixed IPv6 typo. There we go. Very good. So it will make sense now to just do a quick ping test, right? Make sure that we're able to ping the addresses in the neighbor router. So that's what I'm going to do. So run ping 192.168.30.2, which is the corresponding neighbor address in router B. And sure enough, there it is. Okay. In these devices, ping is not going to stop by itself. You have to stop it. So Control C. And now let's ping the IPv6 address. So run ping FE34 36OC 5599 0AE6 column 2, and there we go. So we're pinging now, meaning the first step of our lab is complete now. So now let's go back to our slide and see what's next. So what's next here is configuration for Fast Ethernet 002. However, notice there are two different colors in the topology. The one which is like yellowish on the top is on the master routing instance or default routing instance, and it's what we have just configured. We didn't have to do anything routing instance wise because it's on the default routing instance, Fast Ethernet 001. But this is where routing instance creation comes, because we're going to create another instance called, very originally, additional instance. Okay? And what we're going to do is we're going to create this instance. We are going to create configuration for interface Fast Ethernet 002, and then we're going to associate Fast Ethernet 002 on each of the routers to its new instance. So let's start with interface configuration and then with instance configuration, and we'll see what comes next. So just regular configuration for now, regular interfaces configuration, that is 2.0 family INET address, and then according to the diagram, this one is a 172.25.30.1/30. And when it comes to INET 6, see, the actual address is FD09 36 4C 2322 0DE6 colon 1/64. Okay? Good. So this is my interface configuration. Now I need to go ahead and create a new instance. How do I do this? Set routing instances. And then I'm going to give it a name. It's going to be called additional instance. And then instance type, it's going to be, well, let's just put a question mark. Remember I told you in the previous slides about the different instance types and what they are for? In this case, we're only interested in creating a virtual router. So just a separate routing instance which creates virtually another router with its own routing table, so I can have flexibility in my router topology. So instance type virtual router, and guess what? Interface FE 002.0, and this includes the configuration for each of the address families. So fairly easy, fairly intuitive. So show compare. Then it gives you the configuration for the interface. Then it gives me the configuration for the additional routing instance. And what I'm going to do is I'm going to commit these changes. Commit comment jbar new instance FE 002.0, and I think that's enough of a comment for this particular change in the configuration. So we're committing. And what we're going to do next, as soon as this commits, is just doing the mirrored step on router 2. So we can then communicate the two routers on on their particular additional instance. Okay, so now I'm moving my cable to router B, and I'm setting up, or starting to set up, Fast Ethernet 002, sorry, Fast Ethernet 002.0, family iNet, and then the address in this case is going to be 172.25.30.2/30, and for iNet 6 we're gonna do address FD09 361C 2322 0DE6 colon 2/64. Do a show compare. So now we need to create the routing instance in router B to pretty much match what's on the topology diagram. So set routing additional instance is the name, and now instance type virtual router. Okay, and then we add the actual interface associated to it, which is Fast Ethernet 002.0. Okay, show pipe compare, and there we go. So commit comment jbar created instance plus FE002. Good. So one thing I want to clarify, just so we don't get the wrong idea. Routing instances are relevant to the router where they are applied, meaning they are locally significant. There is no parameter shared or sent between router 1 and router 2, or router A and router B, sorry, that somehow the instance names have to match, or somehow both need to have exactly 2 routing instances. Nothing of that nature. So I don't want confusion, because I'm doing a pretty symmetric example here where the 2 routers have just exactly 2 routing instances and they are named the same. This is just for simplicity purposes for the training, okay? But those are not requirements, okay? This works as virtualizing a router, and you're responsible that the design makes sense, so the routers will not check anything with, between themselves, or not check anything related to instances, whether they match or not, at least when it comes to virtual router routing instances. I hope this is clear. Okay, so what now? Well, what we need to do is do a ping test, just to make sure that it works, and if it does, we would have achieved our goal for this lesson. So what I'm going to do is I'm going to ping run ping, and I'm gonna ping the Fast Ethernet 002 iNet 4 or IPv4 address on router A, and that address is 172.25.30.1. Okay, see what happens. No route to host. Are you guys getting the same error? No route to host. Well, let's verify if that's true. So show route. Oh, sorry, it's a run show route. Run show route, and then 172.25.30.1. See what we see here. Okay, so it shows me that there is a direct route, and it is in additional instance iNet 0. Okay, that is the routing table. As a matter of fact, if I simply do a show route, yet again, a run show route, something interesting happens. See, the first thing, it shows me inet 0, and it gives me the actual routes for the master or default routing instance 192.168.30.0/30, which we had defined before and we have tested successfully. But then now it shows me yet another routing instance. This is not the same routing table, and this is what we wanted to accomplish: isolation. Okay, so it does show me that there is a route to 172.25.30.0/30. Okay, and it even shows me the inet 6 routes for the default routing instance, and also the ones we defined for the additional routing instance. So there is no way that it is routing what is affecting us. So what is affecting us? Okay, and I wanted you to see this error so you won't forget how important it is when you're working with routing instances to actually call routing instances when you're doing your commands, your operational commands. Whether it is a telnet command, whether it is a ping command, a traceroute command, you always have to specify the routing instance. So let's do a run ping 172.25.31 routing instance, additional instance. Sure enough, it's pinging perfectly. Okay, it was not a routing problem per se, in the sense that we had routes. It was a routing problem in the sense that when you ping without any further specification, by default, the router is going to source that ping from an interface in the default routing instance. And it tells you, well, no, I don't have a route. Well, because it's true. The inet.0 does not have a route to 172.25.30.1. The additional instance.inet.0 has a route, and this is the reason why you have to specify the routing instance when you're running those commands. Let's do the exact same thing, but for inet6 or for IPv6. Run ping, and then fd09 column 36 1c column 2322 column 0de6 column 2 routing instance, additional instance. Ping goes perfectly. What if I remove additional instance? Just ping, no route to host. Okay, remembering this might save you a ton of headaches later. When you might wonder, well, I configured everything, how come this is not working? Well, just need to call the routing instance from your operational command. That's pretty much it. So effectively, as you can see in the third slide, this is the resulting virtual topology. This is the resulting virtual topology. So I'm putting here router AM as in master instance, and router BM as in master instance, and then router AA as an additional instance, router BA as in additional instance. So I'm just naming them differently for the purpose of the explanation, although the router is just called the same as it is. Nothing has changed. But what I'm saying here is, because of you virtualizing the router instances, it is now working as two different routers. It's one router contains fast Ethernet 001, then another contains fast Ethernet 002, because there are different routing tables. This is a concept which is very important for you to grasp, so you understand the technology you're working with. Now, you might wonder, well, are there ways to communicate instances with each other? Yes, there are ways, but for now we're learning the opposite. We're learning the separation that it achieves, or that you can achieve, using routing instances. And for this course, this is what matters. About ways to communicate routing instances, we will learn in an upcoming series on JNCIS ENT. Okay? So now for a bit of knowledge validation. The following genus routing tables are associated to MPLS operations. Choose all that apply. A, inet 0, B, inet 1, C, MPLS 0, or D, inet 3. The answer being C and D, MPLS 0 and INET.3. The following genus routing tables are associated to multicast operations, and then choose all that apply. Option A, INET.0, Option B, INET.1, Option C, INET.4, Option D, INET.6, Option E, INET.2. And the answer is options B, C, and E. All three of them, INET.1, INET.4, and INET.2, are related to multicast operations. A third question for you. The following are possible uses or possible use cases for creating a user-defined routing instance. Option A, to create virtual firewall. Option B, to create an isolated VLAN. Option C, to use VPLS or MPLS Layer 2, Layer 3 VPNs. Option D, to create isolated routing instances. Option E, to forward packets by source address and other criteria than destination address. The answers are C, D, and E. Okay? VPLS or MPLS, yes, you can create user-defined routing instances for running these features. Okay? It's not a virtual routing instance, but it's a routing instance, nevertheless. Option D, to create isolated routing tables. Yes, this is what we did in the exercise. Option E, to forward packets by source address and other criteria than destination address. This is otherwise known as policy-based routing, and yes, it can be achieved with the use of a forwarding instance.